Hi, everyone. Thanks for joining us today. This is Caroline Griffin. I'm the Events and Operations Manager for Riot. We're really excited to have Mark Phillips from Helium here with us today. Helium has been a partner of Riot for about a year now, so we're super excited. This is their first Lunch and Learn, and able to do it virtual, which works out well because Mark is on the West Coast. But just a couple reminders, this Lunch and Learn presentation will be recorded and posted on Riot's YouTube channel and also on the Meetup page. And if you have any questions, please put those in the Q&A box and we will make sure all of those get answered at the end of the presentation. Without further ado, I will let Mark take it away.
Great. Well, thank you very much for having me and giving me the chance to talk about Helium today. One slight correction, however, I am not based on the West Coast. I am in Boston, Massachusetts. Most of the Helium team is in the Bay Area, mostly around San Francisco, but I'm one of the few who wasn't based in the Bay, but now, with all of us mostly working from home, it doesn't really matter where we're based. So I've got some slides here to cover the sort of basics of the Helium network. I imagine some people here are somewhat familiar with what we're working on, but I figured some basics would be good. And then if the sort of technical and presentation gods cooperate towards the end, we've got a little bit of a surprise. I'm going to have a community member who, I'm not sure if he's on the call, but maybe Caroline can sort of give me a yes or no, talk a little bit about a very interesting project that he's been building on Helium and deploying, which is a connected chicken coop, which is quite a fascinating and sort of very useful and obvious use case for an IoT network like Helium. So hopefully we'll get to that, but I'll get right into it. So let's see here. So a bit about Helium. So we were founded actually in 2013 by a guy named Amir Halim and Sean Fanning, who people might remember. Sean Fanning, famous for things like Napster and Path and Rupture, which is a gaming company. And the mission back then was roughly the same as it is now. We were raising money to build a ubiquitous wireless network. The sort of decentralization component and how the mechanics work sort of came over the last 2 years, but the goal was always the same. We wanted to give people like Joey Hiller, for example, who's going to talk about his application, or any of the use cases I'm going to cover, a wide area, low power network that they didn't have to worry about. And so we've got backing from companies like SV Angel, Google Ventures, Mark Benioff, Multicoin Capital, and they're sort of all behind this vision of ours, which is to build a network which satisfies, in our mind, the wholly inadequate sort of state of wireless connectivity for devices and sensors. And so anybody who's remotely familiar with the space, as I imagine most people in our IoT group are, you've seen those crazy projections from the Ciscos and the McKinseys of the world with the hundreds of billions of devices. It's not getting there, and primarily in our mind and our thesis, because of factors like this. So when you're deploying sensors to a network, you want to be able to, in most cases, expect years of battery life, right? You don't want to have to go in the field and update a sensor because the battery died after a couple of months. You want a tiny form factor. So, most of the people that are building on the Helium network are using, so I'll get into it, but we use a wireless protocol called LoRaWAN. The sort of form factor for the devices can be as small as 20 by 20 millimeters, for example, depending on if you need casing around a module that does LoRaWAN, and if you need an external processor. So you want tiny form factor. You want these things to be getting smaller and smaller and sort of being hidden over time. A lot of the location tracking applications are sort of going that direction. On that topic, location tracking without cellular. So the Helium network is an alternative to cellular connectivity. And in most use cases, we're seeing people use Helium over cellular for a variety of reasons, primarily for things related to cost, ease of development, and battery usage. Location tracking for things like scooters, cars, assets that are in the field for part of your business, could be cattle, for example. It might be chickens, although that'd be a little bit interesting. People want to be able to track location of assets without having to use a cellular network for obvious reasons. And so that's a huge use case that we're trying to solve. You want to be able to get miles of range. So I'm going to talk about how the Helium network is built by thousands of individuals in the United States and soon abroad. They're deploying in some cases, modest but not crazy antennas that are tied to the Helium Hot Spot, which is our wireless gateway. And these things are producing, in some cases, 25, 30 square miles worth of range from one hotspot. And it's quite remarkable. And so the sensor gets to take advantage of that sort of network range. You want to be building on non-proprietary technology, or at least we think you want to be, and our customers are sort of proving this. So everything I'm going to talk about today is largely open source under friendly licensing like Apache 2 and MIT. And that's a core part of the network. We are really building something that's open and decentralized, and we want it to be sort of a foundational piece of it as things move forward. And then lastly, you want sort of security at every piece of the stack, whether it's the sensor itself all the way up to the cloud. And so these are the sort of building blocks for the network that we're putting out there. And so we started sort of on a redesign of what the Helium network was back in 2018. And what we landed on was what we're calling the Helium network, but we call it the world's first peer-to-peer wireless network. And more lately, we've been taking to calling it the people's network. And so if you've looked at anything related to Helium, you may see us talking about the people's network. So most of our customers over the last 5 or 6 years were building things that should be fairly obvious when you think about them. So refrigeration monitoring, agriculture monitoring, right? Doing automation for things like water and irrigation. They're doing location tracking. They want to do environmental monitoring on the network. What tended to happen was we would get into a POC or a proof of concept and see a quick success, right? So the way the platform works generally is you have some device that's using a wireless protocol that we understand. At this point, it's LoRaWAN. It may expand. It talks to a gateway, whether that's a gateway that you've deployed or a gateway that just happens to exist in the network. And then that data gets backhauled to your cloud application. Maybe that's running in Azure IoT, Google Cloud IoT, AWS IoT. And so the architecture generally worked. The problem is once an enterprise got to the point where they had to deploy coverage themselves, they started to feel very constrained, right? An enterprise that's deploying temperature monitoring inside of, let's say, a Starbucks, for example, they don't want to be in the network building business. They want to be in the business of selling coffee, and they've got a use case to monitor their refrigerators to comply with local regulations and make sure that their food is safe. So we went back to the drawing board and said, how do we get people to help us roll out this wireless network much faster? How do we level the sort of CapEx problem when it comes to rolling out wireless? The telcos are spending tens of billions of dollars a year securing roof space and putting up huge towers. Other sort of LPWAN or low power wide area network players, companies like Sigfox, for example, they've spent $250 million trying to build coverage with the same sort of telco model. So we decided that we'd take an alternative approach. And so we came up with this crazy idea. And around 2018, it wasn't that crazy, to put a blockchain in the access point. So it started as a joke. Somebody wrote this white paper. We kicked it around the office. We drank some more whiskey. We joked about it more. And then eventually we came to a design that we thought was actually quite sound. And so we landed on this incentive-built network where we were sort of going to marry supply with demand, where supply would be people actually building the network. And so I'll talk about this, but we've got 3,300 hotspots out there today with twice as many sold and coverage in some part of all 50 states in the US. And then with demand, right? So we were going to bring that supply to the people who need the network. These would be the scooter companies. These are the sort of smart ag product companies. These are people like Joey Hiller who are building connected chicken coops. So what we built was this thing called the Helium Hot Spot. I suspect that a few people that are listening to this meeting or this presentation, in addition to Joey, probably have hotspots. We have a fair amount of hotspots that have been deployed in North Carolina and sort of on the eastern seaboard, mid-Atlantic states. So the hotspot is two things. And I'll talk about the end if people want to buy a hotspot. You can also build your own hotspot, which a lot of people are starting to do, and I think is a very, very cool piece of our story. So it's two things. So it's a wireless access point that creates, like I said, in some cases, 25, 30 plus square miles worth of coverage using the LoRaWAN wireless protocol. So people might be familiar with LoRaWAN if you're in and around IoT. It's a standard that's managed by a company called Semtech, and it's been getting better and better over the years for doing long-range, low-power communication for devices that are sending small data. And originally, if anybody's actually read the white paper, we talk about something called LongFi. And so LongFi was actually going to be an alternative to LoRaWAN, but the ecosystem came along so well, and Semtech actually started getting much more comfortable with being open about their protocol that we decided to switch to LoRaWAN. And we did that in January of this year after we had the network fully rolled out. So we updated thousands of hotspots to support LoRaWAN versus this thing that we were calling LongFi. And so now we have the largest largest public LP WAN in the United States, and we got there in just 8 months. So the way that we got there was with this incentive model. So this hotspot, in addition to providing access to sensors, right? So if you're in your house or you're sort of walking through a city like San Francisco and you've got a location tracker on your dog or your cat, this will, in San Francisco, connect to one of, I think, 200 hotspots at this point. But the reason it got deployed is because people are putting these in their homes and their businesses, and rental properties, condos, to provide coverage, but also be compensated by the Helium blockchain. So the hotspot is a very, very, very cool piece of hardware. I can talk about what the sort of what it's built on. The primary component is a Raspberry Pi 3B Plus, but there's some interesting stuff in there to do the blockchain component, specifically the security piece. But that is the heart of the network. It's a Helium hotspot. So what you're looking at here is the Helium mobile application. So if you go to the application or the iOS App Store or the Google Play Store, you can download something called Helium Hotspot. And this is a combination hotspot deployment and management application and network visualizer. And it also is your Helium blockchain wallet. So the Helium blockchain is new. We've designed it from the ground up for this. There is a cryptocurrency associated with it that is called the Helium token, HNT. And so the wallet is used to manage your tokens and also deploy hotspots. And so what you're looking at here is what's called a proof of coverage challenge. So this is the city of San Francisco. And what you're seeing here are a series of hotspots participating in what we call a challenge. So if anybody is familiar with blockchain, Bitcoin has something called proof of work. There's other things like EOS, which have proof of stake. Helium has proof of coverage. And this is basically some amount of meaningful work that let the participants, in this case, the Helium hotspots, prove that they're doing something useful for the network, and then in turn be rewarded with, in our case, HNT or Helium tokens. And so useful work for us isn't, hashing something a million times to figure out, some result that matches what's supposed to be produced. For us, it's actually creating meaningful wireless coverage so that people can deploy devices and sensors that connect to the network, and they can ultimately, fulfill some use case or business application. So what we do is we construct what we call a proof of coverage challenge, where a hotspot is responsible for submitting a challenge to the network or to the blockchain, and then essentially interrogating or challenging sort of a series of hotspots in a predetermined way, such that they can prove that they're providing wireless coverage. And so what's happening here is we give the hotspots these fantastic names. So Wobbly Clear Bison is the hotspot that kicked off the proof of coverage challenge, and I can actually point people towards the code that generates these names. It's quite an interesting piece of the network. People love them. So the Wobbly Clear Bison, which lives somewhere not in San Francisco, created this proof of coverage challenge and decided that the Delightful Stone Beetle was the first challenge participant. And so the Delightful Stone Beetle will then decrypt this packet that it receives, send a signed transaction back to the Bison, and then forward on that packet to see if it can complete this proof of coverage challenge. And so lots of proof of coverage challenges fail, many pass, some sort of have a middle ground. And so based on how your hotspot operates here, your ability to earn Helium tokens generally goes up or down in the network. That's the idea of a proof of coverage challenge. And the really powerful thing is that we use this unit of work, proof of coverage, to sort of ensure that we are providing useful network coverage to people in San Francisco. So, the result of this is that we can tell any customer of ours or anybody building a device that in San Francisco, you can generally get, cellular coverage using the Helium network. And there's about 15 to 20 cities in the United States at this point that have this sort of promise, and it's pretty amazing. So this is another look at the proof of coverage. This is happening in New York. I think this is specifically in Brooklyn. Yeah. So again, we've got a hotspot that constructed a challenge. It submitted it over the peer-to-peer internet to this Sable Otter, proper Sable Otter. And then we have a 3-unit proof of coverage challenge here. And these yellow dots, these bigger ones, are actually what's called witnesses. So we have a system that ensures that packets that are transmitted from hotspots in POC challenges, or POCs rather, can be witnessed, much like one would witness, a car crash at an intersection, and reported onto the blockchain. So these yellow circles here are witnesses: Proud Azure Goat, Proper Boysenberry Koala, et cetera, et cetera. That's a proof of coverage challenge. That's sort of the crux of how the network gets built and how the incentive mechanism sort of works and why people are deploying these. So this is the Helium app. So again, I mentioned the application is for managing hotspots. It's also for managing tokens. So over here on the right, you can see some events. And this is an older screenshot. So we actually have been doing a lot of good updating to the app. If you download it today, it'll look a little bit different from this. So we tell you when you do things like join a consensus group. I won't get too deep into that, but the consensus group is the smaller group of hotspots that's elected. In our case, it's every 30 minutes to verify all the transactions. You have tokens here on the left, which are earning for mining and doing operations like routing packets. But in this situation, you're verifying coverage, you're submitting proof of coverage challenges. Yeah, so that's the Helium application. And I encourage everybody to go to the App Store or the Google Play Store and download it. I want to talk about a few use cases before I kick it over to Joey, but are there any questions that I could answer about the network, Caroline? I always like to pause at this point.
Hey, yeah, thanks, Mark. We do have a couple. So the first one is, how many LoRa base stations are required for what level of geolocation?
Yeah, geolocation. That is a hairy problem. That's a very good question, whoever asked that. The short answer is I don't exactly know. So the ultimate promise of LoRa and LoRaWAN is to do what's called time difference over the air, generally, TDOA, which will let you, independent of GPS, actually triangulate the position of a sensor. So, when we talk about location tracking use cases, so for example, I'll talk through this example momentarily, but this is a location tracker in New York City using the sort of same coverage that was responsible for this proof of coverage. So, this is a tracker that's built with a GPS antenna and GPS module, and it doesn't use cellular, it uses Helium, but it still requires the view of a couple satellites from a GPS infrastructure to sort of get location. So there have been some wide-scale tests done of LoRaWAN to do, GPS-free location. Even with sort of remarkable saturation, where I think remarkable saturation is probably 4 every square kilometer, you're only going to get tens of meters at best. I think at the 99th percentile, and I think it jumps all the way. I'm going to butcher this data, but it might jump all the way to 50 meters up at like the 90th percentile. So it's a lot of LoRaWAN gateways. I mean, we would like to think that at some point the Helium network will get there. And in cities like San Francisco and New York, we might have a good shot of doing some sort of triangulation, but it's going to take a lot. A lot is the answer. Hopefully that answers your question.
Thanks, Mark. We have another question here. How does someone who owns coverage in an area lend credibility to their processing of the associated blockchain operation?
I'm not sure I totally understand the question. So how do they lend credibility? Maybe have them rephrase the question and move on to the next one, if that's an option. Yeah, I'm not really understand the question.
Yeah, absolutely. The next question that we have was, is Helium currently, and if so, how and what is the pricing model working with automation, PLC, process, and SCADA integrators?
Sure. Yeah, I think you missed a word in there somewhere. Is Helium currently what?
It just says, is Helium, currently, are they currently working with automation, PLC, process, and SCADA integrators? And if so, how and what is the pricing model?
Okay, yeah, very good question. So the Helium pricing is actually quite unique. So we serve in the LoRaWAN world the role of what's known as a network operator. Sometimes it's called a network server, abbreviated as LNS, LoRaWAN network server. But what we're really providing is a full network complete with a web interface and a bunch of APIs to all this data and some very, very slick and growing developer tools. So the way that we do our pricing is actually no one is doing pricing like we are. So you'll have a sensor that either you build or you buy off the shelf from one of hundreds of sort of LoRaWAN vendors. So again, Joey's going to show you a custom motor sensor that he built using Helium and a LoRaWAN module. You can buy a temperature sensor from thousands of vendors, not thousands, but many tens or even hundreds of vendors. So you have a sensor with a hardware cost that is something that you assume either you buy off the shelf or you build. there is a network that likely exists, but in some cases, so for example, if you're deploying inside of a facility, you might need to deploy an additional hotspot to provide coverage where you need it to be. So hotspots are priced at $350 US right now, and they go down by volume if you want to buy 10, 50, 100. And then from there, the only fee for using the network is what's known as a data credit. So I don't think I have anything in my slides about data credits, but a data credit is you can almost think of it as like an Amazon compute credit or a cell phone minute that you used to have sort of whenever people bought cell phone minutes, maybe 10 years ago. So the idea is that for every packet you send across the network, and specifically it's 24 bytes of payload, you're spending one data credit. And so that data credit has a fixed cost. The full cost is 0.00001, sorry, 0.00001 US dollars per data credit. And so the best way to think about it is that if you're sending one packet every 5 minutes for an entire year, the full cost is $1, like roughly $1.02, right? $1.02. And that's the only fee that you pay to use the network. And we have an interface, or we'll soon have an interface in the Helium Console that allows you to buy data credits, much like you buy, like I said, cell phone minutes, compute credits, Twilio SMS messages. It sort of just re-ups as you need it. And so that's the only required component for pretty much any deployment. So if you're talking about a PLC deployment inside of a factory, that is sort of the only thing that you need to think of. Helium as an entity sells sort of larger support and services agreements, much like Red Hat does on top of Fedora, for example. But to use the network, you only have to pay that data credit fee. And the interesting thing about that data credit fee is that it actually goes back to the hotspot operators. So I'll try to tie this into the thing you're seeing on the screen here. So here's New York City. This is, I think, Midtown. And this is a web application that we have called Cargo. So you can go to cargo.helium.com and actually see a bunch of live data from trackers that are using the Helium network. It's a public community provided website application that we operate, and it's just an open piece of location tracking data. So on the right here, you can see a bunch of these hotspots. So you've got sleepy pistachio cuckoo, the boa, the blackbird, hippo, crocodile, etc. And you can see the sort of the location tracking path. So these are all dots that are coming from that sensor and transmitting in real time to the Helium network. And all these lines here are actually hotspots that are seeing this, or I guess technically hearing this packet in RF world. They can hear this packet and provide coverage to it if needed. Now, that data credit for this packet, so that's rough count here, I don't know, call it 200 location tracking lats and longs. That costs this operator 200 data credits, and those actually end up getting paid to the hotspot that routed the traffic and get converted into a Helium token at the end of a sort of a pipeline, if you will. So that's where that data credit goes. Helium doesn't actually take that fee. That goes to the operators, and that's how they get compensated. So hope that answers your pricing question. Did you get a rephrasing on that other question, Caroline?
I did not. So we'll make sure that you connect with that individual separately.
Yeah, you can always give them my email. I'm happy to answer it.
Great. We have a couple more questions. Do you want to move forward? We can answer these now, or wait.
Let's keep going, and then we can come back to these at the end. So so this is a location tracking use case, and this is a super good sort of illustration of all pieces of network, both the demand side, which is a location tracker, like I said, on a dog or a pet. We have a couple companies that are actively building this on Helium. And then on the supply side, I mean, this is pretty remarkable, right? We've got a hotspot out here in it's either Queens or Brooklyn, probably Brooklyn, Greenpoint, Williamsburg. In Brooklyn, that's many miles away, that's providing coverage to this thing. So even in a city like New York, I think we've got about 200 hotspots between Manhattan and Brooklyn and then Jersey, just over the river. We're getting really good coverage. I mean, in north, on the north side of the island, or the high side of the island, our coverage is not as good, but the supply of network coverage is there, and it's actually really exciting to see these use cases roll out. So these stats are actually a little bit out of date. So we're in, we had a testnet starting in November of 2018. We launched August 1st, 2019 in Austin, Texas, and then it just expanded as quickly as we could from there. We are in all 50 states, and I think most of the US territories at this point, and then we're in over 1,000 cities in the United States. So the sort of, the ramp up has been remarkably fast. And like I said, we have the largest public LP WAN in the United States now, which is pretty remarkable for only having been at it since August. So I'm going to talk about a few use cases, and then is Joey on the call, Caroline?
Yes, he is. So he actually just unmuted himself. Hey, Joey. Joey, you should be able to speak. I made you a panelist.
Okay. Well, I'm going to rip through 2 or 3 use cases really quickly and then kick it over to Joey to talk about this chicken coop of his. But briefly on the sort of enterprise side, this is a sort of the demand that we're seeing for the network. So vial tracking of pharmaceuticals, for example, there's a lot of interesting ways to, or rather, there are a lot of really important reasons why you want to track both the location and the integrity of drugs. I mean, especially in this ridiculous time we're living in, whether it's vial tracking or it could be ventilator tracking. We've done pilots around that, or actually an interesting one that we're doing now is around an alternative to ventilators called helmet-based ventilation. These are all great candidates, and in fact are being used on the Helium network. And the sort of construction here is similar to what I showed you before, where you've got a sensor that is enabled with the GPS and maybe some like an accelerometer to tell if it's been tipped over, and then a temperature to know exactly what the temperature conditions were at various points. Talking to either a hotspot that's part of the public network or something that this operator has deployed. And then this all gets used to build this vial tracking application. Pet tracking, we talked about that. This is a slam dunk use case for the network. We've got 2 companies building on this now. And I think we've got a lot of people who buy hotspots actually end up buying sensors. And we're actually about to do something nice for our hotspot operators in the way of a sensor that will solve this problem. And so people just buy a location sensor and they sort of put it on their cat or their dog, and it works in the area where they sort of live because they're already providing their own coverage. And then for micromobility, it's a little bit of there's not a ton of scooters out there right now, but we anticipate that'll pick back up. Same goes for bikes and rickshaws. If you go to cargo.helium.com, a lot of the assets that you're seeing on that site are bikes, for example, from a few pilots that we've done in Austin, Texas with big companies that you've heard of. So again, this is a slam dunk use case for us. Without a cellular network, you can get accurate and sort of timely location data out of a scooter. It brings the cost of the tracking down. And with something like a scooter provider, they're losing a huge percentage of their inventory because they just don't know where it is. So the Helium network provides a fantastic solution for that. Okay, so I want to give it to Joey, and let's see if I can stop sharing. And Joey, can you hear us? Hear me? Are you there?
Yep, in here.
Cool. All right, so let's change to one thing. Take this over here, and now Joey's got this fantastic keynote deck that is riddled with these very useful videos and GIFs, and I don't want to lose that effect here. So Joey, you're based in East Bay in California, right? Just across the bay from San Francisco?
Yep.
Yeah, and so what do you do when you're not building chicken coops?
Yeah, so day job is I'm a product designer, and so I design software, work with engineers, the whole gamut of the tech job kind of thing. And yeah, right now we're building marketing software, new. So okay. Very tangential to chicken coops, but
yeah, it's totally coupled to chicken coops, I would say. The marketing software. Okay, can everybody see the slides here? Hopefully it's just one big thing. This is blockchain chicken coop. Okay, great. So I'm going to have Joey, who graciously offered to jump on here, sort of talk through this application that he built on Helium. And hopefully, I imagine there will be some people on this call who actually might find this useful. And without giving too much away, I think Joey might actually be in the process of making what he's about to discuss. I think that's sort of more available to people outside of him. So anyways, I'll kick it over to Joey. And then Joey, whenever you want me to sort of kick the slides forward, just give me a go ahead.
Yeah. Cool. So I sort of started this project. We were talking in a chat channel with some of the other Helium folks, and it's like, well, what sort of things would we build on this platform? And I threw out the idea of a chicken coop because it's something that had been in the back of my head. My parents have chicken coops way out on the corner of their property, and they have this daily conversation of like, oh, did you put the chickens in yet? Because if you don't, they get eaten by raccoons. And this just seemed like an awesome opportunity. Finally, there's technology where I don't have to sort of worry about range with Wi-Fi. It's low power. These dev boards are super capable now with battery management and all sorts of like really cool features in there. And so, yeah, I got these dev boards in and sort of kicked off the project. I'll let you go ahead, do the next slide. You sort of did a little intro for me, but yeah, I'm a product designer. When I gave this presentation about a month ago, I prefaced it by saying that like I do know how to build things well, but that's not what you're going to see in this presentation. This is very much just getting prototypes together to start thinking about the actual like thing that I'm trying to build. So solve a problem really quickly in sort of that agile way. So yeah, as I mentioned, this is one of the dev boards that you can pick up. This is called the TTCo ESP32 board. So yeah, it's got the ESP32 on board, so it's a dual core, pretty quick microcontroller. It's great, like deep sleep functionality, all that. You're seeing it pictured with a super tiny. I can't remember how big that battery is, but it's about
Looks like
enough. It's
tiny.
Yeah, it's a 100 milliamp hour battery that I put.
That's what it says, 100 mAh. Yeah.
Tiny little drone. That alone, without doing any software optimization, is enough to run this board for 15 or 20 minutes with just like constant pinging. And that was pretty cool to get that running and just sort of like as a hello world, get this thing sending some data to the console.
And then just really quickly before we move on, so sorry, may have been about to talk about this, but what does this board cost?
Oh yeah, I think I got 2 of them for less than $30. So they're 12, $13 for a board. And that's with the antenna.
Okay. And then yeah, so the primary components are the processor, and then you've got a LoRaWAN or LoRa module on there somewhere, right? Do you know which one that is?
I think the
top right, maybe.
That is actually the LoRa module that you're looking at there. The ESP32 is on the back side of that board.
Nice. Cool.
Yeah.
Thank you. But yeah, it's in the other shot, I think. No, it's not. Right? Yes, it is.
No, we're looking at the same side in both pictures.
Same side, yeah. The antenna's on the same side. Cool.
Yeah,
all right,
so
sorry.
The back side's got your battery connectors. It's also got Wi-Fi and Bluetooth on board. Like I said, super capable boards. Yeah. We can go ahead and jump over. So yeah, after getting these boards in, I did a lot of research, like looking up what are the libraries that are available for handling the LoRaWAN protocol. Eventually found the LMIC library, which is, I guess I'd say is like the go-to library as far as LoRaWAN goes.
Yeah, that's about right, yeah.
And so you did a lot of reading, figured out what my pin mapping needed to be, plugged it all in, hit compile, and right out the gate, this stuff started streaming into the Helium console. So it was, as far as like 0 to 1, it was actually pretty easy for me not having any actual understanding of like what I was really getting myself into.
And
so
just so people, sorry, didn't mean to cut you off, but just people know, so this is the Helium web interface. We provide this free to developers to use. It's primarily focused on onboarding devices, viewing data, debugging what's happening, and you can view real-time data. And also, this is a little bit outdated, this slide, but we have features around functions, for example. So you can kind of think of it as like a very lightweight Amazon Lambda almost that you can sort of pass data to. And it also lets you do things like configure downlinks to your devices. So if you want to send data down based on some events, you can do that too. So it's just, this is all documented on the developer docs that people can take a look at whenever.
And I spent a lot of time in those dev docs, just working my way through it. Yeah, we can jump to the next one here. So past getting the, oh yeah, there they go. The GIFs are fun. Past getting the actual software side of things working, I had to start thinking about how I was going to prototype out my gate. And so a year or so ago, I had taken apart a copy machine, which if you have not done, I highly recommend it. It is a gold mine of stepper motors and DC motors and gears and bars and all sorts of stuff. So it ended up being a great box to pull out to start prototyping the device that I wanted to build. So I ended up choosing the mechanism on the left. If you go to the next slide, I think I have a picture of that. Yeah, so I pulled a bunch of scrap wood off of a shelf. Parts of these are from previous projects. The top bar is, I think, part of an IKEA shelf that I had to cut off to fit it in a room. Like I said, this is not meant to be pretty. This is meant to build a prototype around, understanding, is this gate open? Is it closed? How long does it need to run? How do I need to calibrate my end stops, etc. You go ahead and go to the next one. So yeah, here is that mechanism mounted to the scaffold that you saw previously. So I've got a little spool of wire sort of in system now. And eventually, if you go to the next slide, I think I have, this is setting up the end stops. I had not used opto-isolator end stops before. So I had, again, from the copy machine, there are a bunch of these in this box. So I decided to use them as part of this prototype. So this is just me figuring out how to work those. So you're in that serial monitor there. The left is your Boolean open/closed, and then the right, I was reading off the analog value of the photo sensor in the switch. In the final prototype, I found on AliExpress, there's really great cheap industrial grade end stops, which I'll probably end up using in the final version. Here, I was just getting the motor going, so I ended up just leveraging 2 relays sort of wired together to handle forward and reverse, which I think will last me for a really long time. Eventually, I'll probably end up leveraging like an H-bridge motor controller, and then I get to do fun things like ramping and whatever else. And we can go to the next slide. Yeah, so here's finally a little video of everything wired in together. So you can get to see the gate sort of go up and down a little bit, along with the motor. Probably a little jumpy just from WebEx, but
Looks great to me.
yeah. There is a video, which I'll share in the chat, of when I first gave this presentation, so if anyone wants to reference it, it's a way to go as well.
I'm not sure if this matters,
Yeah.
but
Yeah, well, I think this does matter. This is, again, just the in the Helium Slack channel, which anyone who's interested in this, I point them that direction. Travis has been super helpful in getting me on board, understanding how to, I'll get stuck on a problem and stare at it and stare at it and stare at it, and then he'll send me a snippet of code and it'll send me back on track. And this is me not being an engineer. Really having to hack my way through this, just taking the parts that I know and sort of guessing at the parts that I don't, and being able to pull together a device that at the end of the day is working.
Yeah, it's pretty cool. On the right, you've got the output from, what is it, the Arduino console, just telling you that things are connecting.
Yep. Yeah. So, I was sending information through and then also handling interrupts. I've as part of the design of the chicken coop, I wanted to be able to control it from the actual chicken coop, as well as an app on a phone. You don't want to have to rely explicitly on, having your phone around in order to close the thing. So it was important to me that there is a physical button to press, and that's part of getting this working.
Awesome.
Yeah. And then I think the next slide is just kind of some of the next steps that I had mapped out.
Oh, I may have accidentally pulled that. I'm sorry about that. I think
that's fine.
It.
I can speak to some of them. There was some steps around getting AWS working, which I've actually, thanks again to the Helium docs and the integrations that are available in the console, I'm able to send that data straight into the AWS IoT console with really minimal setup. And then, next I need to sort of figure out how I'm going to handle that data and build out I've been trying to teach myself React Native, so I'm trying to put together a quick little app that way. And And I also have probably a couple $100 worth of AliExpress stuff that's somewhere on a boat. And once all that stuff lands, then I'll be able to actually pull together the, which I'm hoping will be more a direction of the final prototype, which will be more of a retrofit of a chicken coop as opposed to a sort of cobbled together copy machine chicken coop. So
Nice.
yeah, that's kind of like the early stages of everything. This is all about the span of like a week and a half, I think. And you know, a lot has happened since then, but it's been fun the whole way. A lot of learning.
Yeah, and if people want to get in touch and ask about this, it's just go to joeyhiller.com. Is that the best way?
No, that's all you're going to see is that screenshot.
Okay.
I would honestly, I'd say jump in the Helium Slack, and I'm at Joey in there, and I'm happy to answer any questions or point you towards, you know, things that helped me along the way.
Cool. All right.
And guys, can anybody join the Helium Slack? Is that open to the public?
Yeah, let me get the credentials up there. It's just chat.helium.com. And so if you go there, you'll be prompted to, I think I actually have a second. Here we go. So yeah, chat.helium.com. If you go there, it'll like you'll put your email address in a box, and then it'll sort of send you an invitation to make sure that you join. But I'm going to put this this thing up here to make sure that people. Okay, yeah. So that's the link there. Hopefully people can see that. Chat.helium.com, and so it's just a public Slack channel. As Joey mentioned, the conversations in there are very, very lively and cover everything from the sensor development to the blockchain to hotspot optimizations and antennas. I mean, we've got hundreds of people showing up every day sort of to talk about optimizing antennas on roofs and stuff. It's quite remarkable. But yeah, so thank you very much, Joey. I appreciate that. As you said, hop in on chat.helium.com. If you have a chicken coop, maybe you should consider using this. Joey will maybe hook you up with the hardware.
That was actually, it was one little fun thing that I wanted to add, which is this started as a thing just for my parents, but then folks are like, oh, this is something that I would use. And it turned into a really cool way to expand the network into especially rural areas. So pretty cool how that folded.
Yeah, I love this use case. I mean, it's very, very, it's a great use case of Helium, but it's also just like a thing that a lot of people probably could use, which I think is fantastic. Cool. Okay. Well, thanks, Joey. And so let's see, Caroline, I guess we can take some questions if you have anything else that has popped up.
Yeah, thanks so much, Joey. Thanks, Mark. We do have a few questions. So we'll start with the first one. Can helium be used in small towns and rural areas?
Certainly. Yeah. So let me attempt to, you guys can't see my screen now, I don't think, right? What are you seeing? Anything good? Something?
No, just a blank screen right now, Mark.
Okay. All right. I won't get too crazy with this. Are you seeing this slide now? The blue one again? Yeah. So yes, it can. Yeah. So you know, the vision for this is that we get enough saturation and coverage in a place like the United States and North America and eventually the world. We're about to start rolling out coverage in EMEA actually next week, such that it will sort of exist everywhere. But that won't be the case for some time. People who had early cell phones will recall that a lot of times your cell phones wouldn't work, and then it got better, and now generally it's fairly solid. We were at that sort of the cell phone might not work stage, like 8 months ago, when we were just sort of trickling into bigger cities. And now, like I said, we're in over 1,000 cities in the United States. What we're starting to see here is actually people like Joey who are deploying coverage for their use case, and then creating Helium coverage sort of as a byproduct. It's an open public network. It's a public blockchain. Anybody can connect to it as long as it uses the LoRaWAN protocol and a few other specifics that are sort of LoRaWAN, I guess LoRaWAN specific. So yeah, if you have a use case in sort of a rural town, I would say there's probably not enough coverage for it to sort of work. If you go to this site here, network.helium.com, you can see a live map of all the hotspots in the United States and sort of get a sense. If you're in like Nashua, New Hampshire, there's 5 hotspots up there, right? And so maybe you can take advantage of that. But if not, the hotspots are not very expensive. They only cost $350 US, or you can build your own for closer to 200, maybe a little bit cheaper if you're sort of a somewhat capable hardware and software engineer. So yeah, definitely use them in rural, sort of small towns. There might not be coverage. If there's not, you should get on the network and start building it out.
Awesome. Thanks, Mark. Next question. How do I access the Helium device management console?
Yeah, so you would go to, well, the best way to do it is you can go to console.helium.com and then create an account. You won't really have much to do in there unless you have a device to connect. It's just console.helium.com. It's free to create an account. And you can invite people to be part of your organization. You can build any number of organizations if you've got, a customer base, for example, that you want to give access to console, not access to all of your data. Alternatively, you can go to developer.helium.com, and there's a handful of guides that walk you through onboarding a device to console, hooking up things like integrations, which Joey talked about, help make it easy to send data to AWS, IoT, and other things, and the specifics. Yeah, but just console.helium.com.
Thanks so much. Next question. If 10 hotspots see a sensor report, do all 10 hotspots get the data credit?
That's a very good question. No, they do not. So the hotspot that has the best signal strength, or rather that can hear the packet best, generally is the one that's going to get compensated in that data credit. So if we go back, I don't want to screw up this screen share, but if we went back to the that shot I had of New York City, if you look through those RSSIs, generally that's kind of how we determine the best sort of coverage a hotspot is providing. And so generally it will go to the hotspot that is providing the best coverage as seen in the RSSI. And it's also worth noting that that hotspot, like all the other hotspots that see that packet, they're not routing it for free, right? So they're only doing it in the event that they can actually route that data and get compensated in the form of data credit. There's also reasons why you might want to have more than one packet delivered via more than one hotspot. And so we don't actually make that possible, but we will in the future. And so you can see a future where, for redundancy, for example, you want to get that packet from 2 or 3 or 4 hotspots. Somebody asked about location. Getting data from as many hotspots as possible is key to actually doing location over LoRaWAN in the event that the saturation of network coverage is adequate. So that would be another reason why you'd want to pay for more than one packet.
Great, thanks, Mark. And then a follow-up to that question, can hotspots be private like Synod allows?
At this point, they cannot be private, and we don't have any intention of doing that. Part of the sort of foundational principles of the network is that it's very open and it's decentralized. And so we have plenty of people that ask about making things private, and their concerns tend to be security, but also around saturation. So for example, if someone wants to deploy a bunch of hotspots that are routing, I don't know, like rat trap data, for example, they don't want other people sort of sending data through their network because they anticipate it being a problem. These things send so little data. The hotspots can route, so much data relative to what one sensor could possibly send, or what the hundreds of sensors could possibly send, that it is not going to be a problem in terms of saturation. There's an interesting sort of way to think about it. So one company recently asked us this question, and they're thinking about deploying thousands of hotspots for one sort of nationwide application. And they said, can we get exclusivity? We don't want anybody else using this network. And, our response was, no, we don't do that. That's not how the network is designed. However, if you do deploy 1,000 hotspots and one of your competitors decides to use the network, they're going to pay you to route data back to their application. So in a way, you're doing even better than exclusivity. You're forcing them to sort of compensate you to use the network coverage that they're providing. So anyways, you can't lock down hotspots to devices. We might do a thing in the future where you can whitelist devices such that they're not required to pay data credit fees for traffic that route through your own hotspots. But at this point, it's all open and all traffic is allowed.
Great, thanks so much, Mark. Can you please share the cost for connectivity?
Sure, yeah, so as I said before, the cost for connectivity is, I'm gonna go to the Helium site here and demonstrate or use this nifty calculator that we have to show just how cheap it is. So if I can find a window, I think Dal, actually my colleague, might have popped a link to the calculator in the chat. I'm struggling with.
You did, thanks for sharing that, Dal. For those who can't see, it's helium.com/business.
Yeah, but I can actually, if I can figure out how to get the screen to cooperate, I can show people really quickly. Oh, there we go. Okay, so let's stop sharing, share application. Bum, 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 bum. All right, we'll stop. And then we will share again. And then we will do screen 2. All right, can you see this website here?
Yes, we can.
Okay. Yeah, so if you go to helium.com/business, you'll get this here and scroll down a little bit. And so we have this calculator. And as I mentioned in the presentation, so it costs $0.00001 per 24 bytes. That's like there's a LoRaWAN specific reason for the 24 bytes, but that's generally the size of the data payload that people are sending. So let's say, for example, the example I used when I was talking about one device that transmits a packet every 5 minutes. And then you have you want to see what the cost is for a year, right? This is $1.05, which is remarkably cheap, right? Let's say you've got 100 devices that are transmitting once an hour, which is also another fairly common pattern. Like if you're just doing location tracking, once an hour is fine. If you're just doing temperature inside of a facility, once an hour is actually probably overkill. I mean, that's going to cost you $8 a year, right? So thinking about pricing that into your product, it's remarkably cheap. If it's one sensor sending a packet every hour for an entire year, it's going to cost you 9 cents. That's a light bulb write-off. So anyways, that's the only cost of using the network. It's the data credit cost. As I mentioned, Helium, we do sell end user licensing agreements that are tailored to sort of support and services and deployment needs of larger enterprises. But if you wanted to put 1,000 devices on the network and never talk to us, I'd be sad. But you could do that just by paying data credits.
Thanks, Mark. Is Helium an alternative to the Things network?
Yes, we are a direct alternative / competitor. We're actually seeing a lot of people transition to Helium from the Things network and the Things industries. So I just jumped to our developer site, developer.helium.com. People can still see this, right?
Yes, we can. Thank you.
All right. So, for example, somebody asked about console earlier. So if you come here, we walk you through how to get up on console. But if you've already started using the Things network, we will forgive you for that. And you can come down here and go to a migrating from the Things network to Helium guide. So this will walk you through how to get devices off of the Things network and onto Helium. We do use the same subband. So we're on subband 2 in the United States, and we use the same subband or the same piece of spectrum in the EU, which makes it easier. And so in addition to this nice guide, we've also got a command line tool, which walks you through pulling devices from the Things network, adding them to the Helium console, porting your, in what is in TTN land, your application ID over to what we use called labels. So yeah, direct, very much a competitor with TTN. And like I said, I think in the last month, we had 4 people switch over from TTN and TTI to Helium for a variety of reasons. When I say people, I mean companies.
Great. Thanks so much. The next question is, can a SBC with LoRa surf the web if connected to Helium?
SBC, what do you think an SBC is? That's a good question.
Yeah, you got me there.
Well, at any rate, the answer is likely no. So the sort of LoRa, the physical layer sort of, I guess the MAC layer would struggle to send like more than 5 kbits of data effectively. That's if you had a device that's plugged into power with the radio wide open at all times. So it's very, very much lower bandwidth. I mean, we're seeing most of these devices send much less than that, like, an order of magnitude. So no, not for web surfing. We do have ideas on how hotspots could be used to enable things that look like LTE or 5G connectivity, but it is very much about low bandwidth IoT devices at this point.
Got it. We do have some clarification just for the record. SBC is single board computer.
Oh, okay. Yeah, I mean, you could certainly use the network to connect a single board computer, but it would not be for giving it the ability to do web scraping or something.
Got it. Thank you so much. We do have quite a few more questions. We'll run through a few more. let's see here. This one is more, specific to this gentleman. On the Helium coverage map via browser, I can drill down to a local hotspot. I thought I had been able to see that hotspot traffic info in the past few days, but I'm trying to connect to a new gateway, so I'm trying to make sure the hotspot is up. I can no longer see traffic info for that hotspot. Has that changed, or am I not looking in the right spot?
And this person is actively having this problem, trying to add devices to the network. What is this person's name?
Yes, Leroy. We're addressing your question. If it's easier for me to connect you at the end, we can certainly do that as well.
Yeah, I mean, Leroy, what you should do if you're not in, let's see. So there's an answer to that question, which is we're trying to get better. Actually, Dal from our product team, I think, is on the call. We're getting a lot of good questions about how, a developer can know if there's coverage in an area before they start developing. So, as a unit of one developer, if you happen to live in, Dover, Florida, you want to know if you can connect to this hotspot if you're sort of in the surrounding area. So we're actually actively discussing how to add features to console or maybe some other third-party service that helps make it more apparent if there's coverage. Wireless is very, very hard. And generally you do end up in situations where you don't actually know where the sort of connectivity is failing, which is not to say that we won't attempt to fix it, but it's just something to be aware of. Anyways, Leroy, if you're not in the Helium Slack, I would go to chat.helium.com and register, and then bug Travis Teague, or anybody in the node development channel. We'll give you some guidance there. But thanks for using the network. Pretty cool stuff.
Thanks so much. And another question here. Can you decommission a device so that it stops sending data?
You can, yeah. So right now it's kind of all or nothing inside of console. So you can have you add it or you delete it. But I do know that Dal and the product team have had a lot of requests from our customers around being able to sort of just pause a device for whatever reason. Maybe you don't want it sending for some reason, or maybe the person who's actually paying for the device stopped paying their bills, for example. So yeah, soon we'll have the ability, where soon is a thing that I don't know the answer to. But you'll be able to go in and, whether it's via the UI or via an API, say, hey, pause data transmission for this device, which I guess would mean the console would know to stop routing packets, because we're not going to push a device message down. But yeah, that'll come soon.
Awesome. Thanks so much, Mark. I also want to thank Joey for answering some of the questions in the chat box. So he's taking care of a lot of those, and for Dal for bringing up some really great questions, and as well answering some of those questions. But yeah, thank you so much, Mark, Joey, Dal. Great presentation. And as a reminder, this was recorded. It will be on the Riot YouTube channel and on the meetup page. If you have any further questions that we didn't get to today, I think we got them all, but if not, I encourage you to either reach out to Mark directly, or please use the Helium Slack channel. It seems like that's a great resource to our community. So thank you so much.
Yeah, my pleasure. And so my email is just mark@helium.com. I'm going to drop it in the chat here. And then again, it's chat.helium.com. Chat.helium.com is really the best resource. It's just full of people building stuff that you probably care about. And if you're looking to, find people that are in your geographic area that have already deployed hotspots and can sort of give you wit and wisdom, or maybe, you want to find somebody to help co-develop an application, that's a great place to do it too. But yeah, thank you very much for the chance to talk to this group. This has been fantastic.
Absolutely. And if you enjoyed this presentation, I encourage you to tune in tomorrow at 1 p.m. For our Tech for Good conversation. Mark will also be doing a quick introduction to a very cool project that Mark and Helium have going on with SimTech. And you can find all that information on the Riot Meetup page. So once again, thanks everybody.
Thanks. Bye.